Hello, this is Mrs. Schroeder. Today we're going to talk about how to find molecular formulas from empirical formulas. If you remember from our last section, we talked about an empirical formula being the simplest ratio of elements in that formula, but it's not always right. Sometimes we have molecules that are made up of a lot of atoms, especially when we get to organic chemistry, talking about carbons and hydrogens. There's a lot of different formulas that might really be, even if we just know the ratio of the elements. So sometimes we need to actually find out what the true formula is. One example is the empirical formula CH2O. That's the empirical formula for C6H12O6. So you can see these two differ by a factor of 6. So if I want to find the molecular formula, how do I do it? Take a second, pause the video, and write these down. You have to be given some things. You have to be given the empirical formula and the molar mass. Or the problem might actually give you the information for you to find the empirical formula, in which case that's the first thing you'd have to do is find that. Next step is to calculate the molar mass of the empirical formula. Just like we did in the first section, take each element and multiply it by its subscript to find the empirical formula. Divide the molar mass by the of the compound by the molar mass of the empirical formula, and then that should work out to be a whole number. There shouldn't be any decimals. There shouldn't be any 2.5s multiplied by 3 like we did with empirical formula. None of that. This should be a whole number. And we're going to multiply the subscripts by that ratio. Example of how this works. I find a compound. I know the empirical formula is P2O5. I do that based on percent composition that I'm given. I do another type of analysis, gives me a molar mass. We'll talk about how to do those second semester. But anyway, I find out the molar mass is 284 grams per mole. So I need to figure out what's the true molecular formula for the compound. So step 1, write down what you know. Okay, you know empirical formula, you know molar mass. Step 2, take the molar mass of the empirical formula, 2 times 30.97 from the periodic table. Oxygen is 5 times 16. They rounded off that 15.99, and they get 141.94 grams per mole. That's the molar mass of the empirical formula. Step 3 is to find that ratio, 284, which is what's given up here, divided by what I just found right here, gives me a ratio of 2. And it might be 2.1, it might be 1.99. It's okay, round it off to get a whole number, which I then multiply the P2O5 by 2 to get P4O10. And this would be its molecular formula. That's what the true formula of that compound is. We're going to do another example that we're going to do together here. On page 245 of your book, it tells you that the compound has an experimental molar mass of 78 grams per mole. Its empirical formula is CH. What is the molecular formula? Well, first step is to write down what we know, which I did that for you already, 78 grams per mole. Empirical formula is CH5. Next step I'm going to do is figure out what my molar mass of the empirical formula is. And I take the carbon plus hydrogen, and I get 13.019. And that's grams per mole. Next step I'm going to do is take my 78 that I'm given, divided by 13.019. That equals 5.99, which is approximately equal to 6. Okay, that's the ratio of the molar mass of the compound to the molar mass of the empirical formula. Now I'm going to take my CH and multiply that by the 6 to get the formula of C6H6. And this is my molecular formula. So in summary, make sure you know your vocabulary. You have to know what empirical formula means, what molecular formula means, what molar mass means. Make flashcards if you need to. First, write down what you know. Next, molar mass of the empirical formula. Find your ratio right here. Multiply by that number. That gives us our molar mass. That gives us our molecular formula for that compound. And we will try more of these in class tomorrow as practice.